Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the zero-noise application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Invicti, AppSec with zero noise. Visit securityweekly.com/Invicti. Passbolt is a free and open source password manager that allows your team to store, organize, and share passwords securely. Passbolt is privacy first and highly versatile. It can be installed on-prem behind your firewall, used in a secure cloud, or deployed as a cloud-native application. You can check out the source code on GitHub, extend it with the REST API, integrate it with the CLI or SDKs, and even contribute. Get started with Passbolt for free now. Check it out at securityweekly.com/Passbolt. UFOs are everywhere. That's right. UFOs, unidentified file objects, are hiding in files in your cloud apps and storage. UFOs can contain malware that exfiltrates data or deploys ransomware. 70% of UFOs in files can't be detected or prevented by traditional scanning solutions like antivirus and sandboxing. That's where Vitiro comes in. Vitiro prevents UFOs before they hitch a ride in on files in the cloud, without detection and without slowing down business. Learn more at securityweekly.com/Vitiro. That's VOTIRO. Welcome back to Application Security Weekly. We just talked with Dr. David Movshevitz about collecting application logs and how to effectively analyze them for security issues. I'm your host, Mike Shima. I'm here with Akira Brand, and it's just about time for the news. But first, one announcement. Follow us on Twitter for live stream reminders, highlighted clips, memes, and more. You can find us at Sec Weekly. And welcome back. I think we missed you last week, Akira.
I missed you all.
And what John and I started off with was a new listener question section that I've so far affectionately called AP I Don't Know. Now, our first question was about three things, as someone new to AppSec could start doing. And actually, one of the things I mentioned was the OWASP SAM, which I think was on your mind at the time as well. This week, we have a slightly different take on this question. So we have someone who is I'm a new AppSec hire. What should I do in my first 90 days? So rather than three things, we're talking about 3 months. And let's turn over to you first, maybe, if you have an idea or two about what you might throw in for this.
Yeah, I have many ideas. I'm actually in the exact same position. I just got hired as an AppSec engineer. So I'm also thinking, wow, what should I be doing during my first 90 days? The things that I can say that I've done so far that have been proven really useful to me is to, first off, get to know the product. You have to understand what it is that you're securing. You have to understand how the data flow works throughout the product. But beyond that, it's important to just know the features of the product and what value that you're providing to your customers. And I say this because if you don't necessarily have a customer-facing viewpoint, I think you will really miss out on a lot of vital information, especially about, like I said, about features. You don't necessarily want to dive into the quirks of the app yet, but definitely just get a broad overview. The second thing I'll say is to start taking some metrics and set some what are called OKRs in corporate speak. That stands for objective and key results, and try to understand where you want to get your metrics. If you are the only person on the AppSec team, then you're on your own here. But if you have an existing AppSec team, they can help guide you a little bit about where they want to be with certain metrics by the end of your first quarter there. What we use at Resilia is we use what's called the CIS score, which is a very common way of measuring the effectiveness of your different sections of your not only application security, but your overall security posture. The last thing that I'll say that is extraordinarily useful is to start to gain allies within within the organization. So when I say allies, essentially what I mean is get to know the engineering managers, get to know the people that you're going to work with. Maybe potentially you have some team leads, or you have some senior engineers that you want to start to get to know, and neglect not the juniors. It would be good to get to know the people that are just starting out. And the reason I say this is because when you have someone that's new to coding, you can start educating them on secure coding sooner rather than later. So they might become one of your most enthusiastic security champions on the team. And I think that's incredibly valuable.
Oh, absolutely. I think my answers are likely going to overlap quite a bit with yours. So I'll just run through them quickly in the sense of I was going to suggest measure something. Just find something to measure so you can establish a baseline. Here is what things looked like on day one, so you can point to it at day 90, or of course year over year, or some other type of trend. This is what this metric or measurement looks like now, and that ties into, I think, what you said quickly. Also is going to crib from John's answer about what 3 things you should do and focus on that relationship building with engineering leadership and stakeholders. You pointed out a great point to don't pay attention to the coders as well, because those developers know where the bodies are buried, to throw out our second cliche of the episode. But in the sense of when you go and start to talk about threat modeling or something else, they understand, oh, if I were to hack, or if I were to target this application, here's how I would do it, because they have that domain expertise. So that relationship building is great. And I think a third thing I would also suggest is similar to take the OWASP SAM, or just look at the list of the 12 Microsoft SDL practices, prioritize their importance to you as the new hire, and then use them to inform your conversations with those stakeholders to get a sense of both what maturity might already exist around threat modeling or software composition analysis or something else, and then use that to inform either a metric or to start estimating a team size and a hiring plan, especially if you're hired on to grow an AppSec org or AppSec function rather than just to be that AppSec person. So listeners, please do send us more questions. We'd love to continue to answer these, as well as try and I guess we can't predict what the interesting ones are going to be. So tell us what the interesting questions that you have, because we also have some interesting articles to jump through. One I'm going to do real quick is a Riot Games. Hackers got some ransomware in there and said $10 million or we release the source code. There was a reason I brought this in, was more to talk about what the implications are of a source code release, because within the past year, we've seen source code released from Okta, LastPass, Microsoft. And normally I kind of shrug and just say, okay, it's source code. As long as it doesn't have hard-coded secrets, it's not necessarily the end of the world from an application security perspective. Obviously, there's IP, those types of considerations. But maybe there's something more to that when we're talking about games and online games in terms of developing cheats or countermeasures to bots or countermeasures to anti-cheating techniques. So maybe I'll have to rethink a little bit of my worries about source code leaks. Kira, I'm not sure where you stand on the risk or the warm fuzzies or lack thereof when source code gets leaked.
Yeah, so I was also deeply intrigued by the anti-cheat source code, and that was what they focused on, as opposed to just the overall source code. If you look actually at the full note that these hackers sent to Riot Games, the first sentence is, "We have obtained your valuable data, including the precious anti-cheat source code," and so on and so forth.
Precious.
Now, I love that it's precious. That's fantastic. But I don't know a lot about why anti-cheat source codes matter. I assume it's because potentially the monetizing of the game would get extraordinarily impacted. Maybe they would lose a lot of users because it would just become kind of a free-for-all with having too much cheating going on. But I was curious, Mike, if you learned anything about that.
Oh, there is a long, long history of overlap between application security, reverse engineering, binary analysis, and cheating within games, all the way back to even Commodore 64 and the demo scene, as well as cracking Commodore 64 games, as well as modern, as we're talking about with Riot Games, of course. And yes, the idea is that if you have an online game and you want to avoid cheating because it just ruins the experience and it makes it difficult. It just make it, I think I can't. It's hard to come up with another synonym for just ruins the experience for other players when you're doing unfair and have seen others with unfair advantage, and you lose users, you lose subscriptions, etc. So that's the type of thing that can hit. I guess where I'm going with that is a threat modeling topic if you have for games, whereas a different threat modeling topic would be if our source code is leaked for an e-commerce system, you probably don't have the similar worry about online cheating, for example, but you may have some heuristics around anti-bots or anti-carding countermeasures. And so if you have rate limiting or alerting at a particular threshold and attackers see that, they may just try to fly under that threshold. So there's always a bit of a cat and mouse game to this, but and that ties in maybe a little bit to our discussion with David just about what do logs show about anomalous behavior, or these journeys that aren't taking expected routes, whether it's cheating within games, doing carding, or some other types of nefarious activity against an application.
Nice.
So what I want to turn us to is some more bugs. So we haven't heard, or I haven't been maybe paying attention enough, of a significant flaw within bind for a long time. And of course, bind is one of the foundational services of the pieces of software, open source, within the internet. There is, of course, everyone just blames DNS. It was always DNS for whatever problem happens. But this, I wanted not so much to focus on the actual flaw here, which was just a network-based attack that could trigger a denial of service against bind, but more of, I was looking at the history of bind because we talk on the show about refactoring and memory safety and memory unsafe languages, things like that, and talking about Linux kernel getting Rust, Chromium moved to some Rust in this area, in several areas, Mozilla starting this amongst the browsers with adopting Rust. And here was a presentation that I found from how long ago? 2014. And the author of this, Shane Kerr, was showing how bind at the time was trying to move from a significant refactor re-architecture from bind 9 to version 10. And they wanted to introduce some Python, some C++. And he talks about after the first year of effort, they had a simple authoritative only server for DNS. So they didn't have a recursive resolver yet, which don't worry too much about the details. But the point more was that they didn't have real users really using it in production. So after a first year, they already had some technical debt because of decisions made because of accelerated development. Nothing was usable for production. Year 2, still nothing was usable for production. They were still building up a lot of different capabilities. And by year 3, still not ready for production. So this is kind of one of those examples I just wanted to highlight when we talk about why suddenly all of the C, C++, insecure software out there isn't just magically rewritten into Go and Rust. And here ends my soapboxy explanation of this. I do encourage everyone to go check out our show notes, read through that presentation. Very well done. Lots of very simple declarative sentences that can teach you a lot of things in hindsight about what to do to make refactors go well.
I also think, Mike, that in every project that I've been involved in that didn't work, like when something just fell over and
more than one, yes, I know the feeling.
Yeah. There's been more than one. Has essentially been during these transition moments, right? So maybe you're trying to refactor. that's a tough spot to be in, right? And in books like the Phoenix Project and the DevOps Handbook, they talk about essentially just the complexity of IT and how it just gets more and more complex with these transition moments, and how they need to be very carefully managed. And I am in no position to pass judgment on this particular project. It's definitely way beyond my coding expertise to be able to even dream of something like this. And the thing that I found interesting is that there was just so much technical debt that was accrued. And I wonder if that was maybe one of the main hinge points of why the project just didn't work, in addition to having the few real users.
Yeah, that one of the lessons learned was that accrual of technical debt so early on, just because of that accelerated development schedule to try to deliver value. And one of the points that the author makes is that there's DNS operators don't necessarily care about the software. They care about the speed, latency, load time, the memory footprints. And so the recommendation there is demonstrate new value from day zero as you're developing software. And also, people fear and hate change, to use the language from the presentation. And the suggestion for that is create a roadmap. Give people a preview of what's to come. Give them expectations that this month, this quarter, this year is when we're going to make this particular change. And be cognizant of when you're overwhelming them or not, just so they can understand, basically avoid surprises and understand what's coming. I wanted to tie this real quickly to another refactor that actually surprised me, because I had to read the title a couple times before I'm like, oh, okay, this is curious. Let's see what their reasoning is, because this is from Twilio, that migrating an authorization service, so that's pretty important, that's security relevant, of course, used by thousands of customers, so it's in production, it's going to be consequential if things go wrong, and they're going from Go to TypeScript, which is kind of interesting. John and I, and you as well, Kara, we've talked about a lot of the refactors that we've seen going from a memory unsafe language into Go, into Rust, for example. But here it's just going from Go, one of the fancy new languages, into TypeScript, a well-established language, also memory safe. But one of the things that I liked about as I started to read is that, this is a strong, well-reasoned engineering decision, because as the article states, they lacked expertise in the Go stack, so they were worried about making any big changes. And the other thing that stood out, worst of all, there were very few tests in the existing Go stack. So once again, if you have if you feel that you don't have expertise or less expertise, and you have fewer tests, that leads to the idea that you're going to have less confidence even in just making bug fixes, or let alone responding to security decisions. So there's a couple more things that stood out to me in this, but I'm curious how this particular article struck you.
Yeah, so one thing that I've learned with authorization is that it can be hugely complex. It doesn't make a business any money, so sometimes it can become sort of like the pariah of the coding world, and it can be intimidating, right? It's extraordinarily complex to put an auth system together, at least at scale, at this scale. So I'm not surprised that the devs were maybe reticent to touch this. I personally think it was a great idea to just go with what the devs were good at. In the article, he talks about how the engineering organization primarily dealt with TypeScript and Node.js servers. So if that's what your engineers can do really well, then I don't see why you would have to necessarily dogmatically stick to a language like Go.
Absolutely. And this is one of those lessons, I think, for AppSec to be flexible, be collaborative with your developers, and rather than just say, use this language, use this memory safe, say, avoid this particular class of vulnerabilities, for example, memory issues. And for example, we're talking about authorization. If you make a mistake in an authorization issue, you're going to get some security vulnerabilities. There's going to be a lot of bug bounty researchers that show, oh, look, here's an IDOR, or here's something else that I can access because of some flaw in this implementation. Mm-hmm. So one of the things that they acknowledged that as one of the challenges. They, as you pointed out, they knew about TypeScript, so why not lean into that? And one of the things about that they also mentioned is that the temptation to refactor came up while they were rewriting the service. So I actually want to be a little bit more precise maybe in that what they mean by here is that they rewrote essentially the capabilities one for one from Go into TypeScript and avoided adding, oh, here's a new feature we can do. Here's this other new feature. Here's an extension we're going to add into this into this part of the authorization process. That's adding more complexity, which is pretty dangerous if you already don't have good testing. So this was, we're going to rewrite in a different language. We're going to have more test harness, more tests, so we can have peace of mind as we develop this. And we're going to maintain at least the same level of security in terms of memory safety, as well as we're going to hopefully, fingers crossed, avoid making mistakes and introduce vulns within this authorization service.
Mm-hmm. And that actually also points to the previous article about accruing tech debt. So the less new features you're trying to add, the less tech debt you might accrue. And then, of course, this was a example of a migration run very well that the team was able to pull off.
So there's a theme that I'm building here. So I'm going to bring in yet one more article and then bring an article that you also touched on this week. I wanted to highlight there was a Git source code audit that John and I actually just alluded to last week when we were talking about integer flaws and integer-based vulnerabilities, because I wanted to mention some great work about the zines that Julia Evans creates around integers and debugging. This Git source code audit viewed as a Rust primer, I thought was really cool because it takes some flaws implemented in C, re-implements them or conjectures how they would be implemented in Rust, and then points out here's how Rust would react. And it's very, I think, fairly taken in the sense that Rust fixes everything is not the hypothesis that the author goes with. It shows, well, here's a memory safety issue that it deals with that it would point out either at the compile time or would complain about more strongly to help the programmer avoid this particular problem. But then there's a lot of other issues like dealing with regular expressions, dealing with some of the other scenarios that Rust doesn't magically and automatically prevent you from. So this just ties into that concept of it's wonderful to move to a memory safe language, but now that you've taken care of that memory safety class of issues, there's a whole other class of issues that you need to deal with, from handling regular expressions to handling the context of user input to as well as things like integer handling and so on. So I wanted to hit that, but Kira, pull in one of this. We've been talking about memory safety. Why don't you pull in that particular article as well into this group we've been talking about?
Yeah, absolutely. So while I was going through articles this week, I realized that maybe our listeners don't necessarily understand what memory safety is. So I put in an article that is a wonderful beginner level intro to what memory safety is and why it matters. So the easiest way to describe memory safety is essentially it's just a way to prevent programmers from introducing certain types of bugs that are related to how memory is used. This article goes into a few of those types of bugs. For example, there's something called out of bounds reads and writes, which is say you have a list with 10 items. You ask for 11th item, you're not going to get anything. You're going to get an error. However, with memory unsafe languages, you might actually be able to read whatever memory contents are existing before or after that valid contents of the list, just due to the memory management. This also relates to things like buffer overflows, which we can touch on in just a moment here. But essentially, there are some memory unsafe languages that are C, C++, and so on and so forth. And then there's the memory safe languages, such as Rust, Go, Java, and JavaScript. Now, that last one I want to mention with a little caveat. I was looking around, and there's actually a little bit of debate that I found whether or not JavaScript is actually memory safe. I thought that was really interesting because from my understanding, it absolutely is. But some people were taking issue with the JavaScript runtime engine. So, Mike, I was kind of curious whether you had heard anything about, is JavaScript actually memory safe out in the wild?
So yeah, I think short answer, JavaScript's memory safe. In kind of end of story. But if we're talking about nuances of the underlying implementation of the JavaScript engine, like V8, for example, or the engine within, like within Blink or within WebKit, the engine itself is implemented in C++, that may have some memory safety issues because those are not safe languages. But JavaScript itself doesn't allow for direct memory manipulation, allocation, things like spatial memory safety, which you highlight is like out of bounds issues, reading past ends of buffers, ends of arrays. Temporal safety, JavaScript doesn't have that. The underlying engine, however, may, in the sense of here is when a object is allocated, here's when it's freed, here comes our use after free or our double free. These are types of kernel, especially kernel level violations that lead to root level, privilege escalation exploits or other gnarly, to use the technical term, fun exploits within the JavaScript engine. But that's where I'd say strongly JavaScript memory safe. The underlying engine implemented in C++, I don't. And maybe a little bit of Rust in Mozilla. I can't remember which parts they're bringing in. Mm-hmm. But that I think is the important nuance there. And I had something else to say, but I completely forgot what it was. So carry on while I think of that.
Beautiful. Okay, great. Let me think what else. I maybe wanted to talk a little bit about another question that I got this week, which was, what are some of the downfalls of using a memory safe language? One of the ones that came to my mind is that you can get sort of this false sense of security, which references back to the article that you just talked about with the Git source code audit viewed as a Rust programmer. Even in dealing with this audit, the Rust programmer also mentions, like, you know what, just because you're using Rust, you could use it somewhat naively and still introduce some security issues. So, Mike, what do you think about that? What's the dark side of memory safe languages?
Honestly, I think I totally understand the question, but I would push back on the framing and say more of, I care less about the language use and more about the users of the language. And that I'll use that Twilio example. They made the decision, Go versus TypeScript. We know TypeScript. We know the implications of the language. We know effective design patterns within the language. Go forth and conquer. Rust, if you know Rust, you can do those same things. Learn it, understand design patterns, implement those design patterns. Be aware that memory safety is not the only type of vulnerability out there. Basically, that will be my repetition for the day, which is often the repetition for the week and for the month. But I think that's why I would lean into that. Yes, you don't magically avoid, or you don't magically create secure software just because you've chosen a memory safe language. You magically avoid a lot of issues because your compiler is giving you strong feedback. You're getting the language itself is either making it impossible or extremely difficult to introduce those flaws. And that's where I'll just real quick use that example of, what is Rust still has unsafe keywords. And even in React has that wonderful function, dangerously set inner HTML, which is the best way to write cross-site scripting, vulnerable code. But they make it really obvious when you're doing that. So it's that obviousness that makes it easier for a linter to look for, to grep for that matter. So that's how I look at this in terms of avoiding a pure language wars type of discussion.
Beautiful. And especially I love how, like you just mentioned, React has the word dangerously. I think we could all, maybe if we were to do a language war, that would just be my only thing, is definitely make it really obvious.
Make it obvious. Let's see. Other things that are obvious, just a couple quick articles that I included as well. One was about introducing kernel sanitizers on Microsoft platforms. So this is just basically Microsoft talking about how they're bringing the address sanitizer into their own kernel, which I think is a good thing. It just points out to the address sanitizer in Clang and LLVM not necessarily new at all. It's actually well established by this point. But what's nice is just to see Microsoft introducing it not only for user mode applications, but going into the kernel. Same thing with that has been done in Linux world for quite a while. So we're talking about C++, of course, or C for that matter, and this is unsafe languages. Be wary of this particular dark side, but there's still tools and compilers that can help prevent these types of issues and point them out at compile time for developers. So it points to how well do you know your language? How well do you know and use the tooling around the language to avoid these types of flaws? So not necessarily saying that you have to throw away all of the C++ code out there, but if you're starting from scratch, probably Rust is a favored choice.
Yeah. Yeah, I mean, there's a lot of nuance in all programming, right? And so if you can use a library or use some tooling around something quote unquote unsafe that then makes it safe, and you kind of like the Twilio article, if you've been writing in C for your entire career and you don't necessarily have the time nor bandwidth to jump to something like Rust, then by all means use C and use the tools that are around C.
Indeed. And, Address Sanitizer is a bit old in application development terms. But what's even older is the SQL Slammer worm. And I wanted to pull this in real quick because I do like pointing back to the history of application security so that we don't forget and that we can learn from it. So SQL Slammer was exploited a vulnerability in Microsoft SQL Server back in 2003. And so this was known, it was quaintly known for exploiting a whole 75,000 systems, which I think in this modern day and age, we can point to several companies that have well more than 75,000 systems on their own internal networks, let alone across the internet. So it was just funny to see the difference in volume of systems affected 20 years ago versus today. But the thing that really stood out for SQL Slammer was the speed that it spread with. So it spread, I think it hit almost 90% of those hosts within 10 minutes. So this was something that was pretty fast, which meant that it was hard to stand up a new SQL server, get it patched on an infected network before it got reinfected again. So the point here is more about patching, learning, and looking to exploit payloads. And I think maybe one thing I can go to here is the utility of blocking egress filtering. So one of the things that made this, that I think helped this spread, is that there was very little practice in egress filtering. In other words, blocking all these outbound scannings, 55 million scans per second coming out of all these infected servers throughout the internet, spreading and spreading and spreading. But if we had egress filtering that says by default, why exactly should our SQL server be connecting to random IPs on the internet? That doesn't seem right. That's not what it's supposed to do. That's almost a user journey that our SQL server shouldn't be going on to. And it also ties back, I think, a little bit into our conversation with David. So that was some fun history for the week. I linked to an article from that gives a good overview, as well as a couple other issues and articles from the web archives, if anyone wants to dive into that more. But I don't know, Akira, if that SQL Slammer has any meaning for you, or just SQL in general has any particular appeal.
Yeah, so I'm relatively new to AppSec, so this is very cool to learn about some of the history. And Mike, you actually answered my question that I had for you, which is like, what is the modern implication of this? Like, what can someone learn from it? And the egress filtering was exactly what you already said. So there you go.
Yes, and that's why I do. We're not trying to be just nostalgic for a past and the days were better, because they weren't in many, many ways, and we misremember the past as well. So I want to make sure we look back, but more importantly, we look forward. Another way of looking forward is that, and I'm going to take a deep breath and try not to sigh too much, is that AI, ChatGPT, GPT-3, it keeps getting mentioned and mentioned and mentioned, and honestly, I haven't seen any really interesting security relevant uses of it. A lot of promise. Machine learning, we did talk about that with David. That has demonstrated uses. here, just a quick article from Orca talking about how they're considering using ChatGPT to explain remediation. I thought this would actually make sense because it ties into also the conversation with David, is rather than explain to someone in the very specific jargon and argot of AWS or Azure or GCP, this doohickey and this gibble gobble and this other, inscrutable thing that if you're not paying attention to the details of what the AWS service naming conventions are, might be hard to figure out. If you can turn that into more plain language using something like an AI, saying this is anomalous because this resource shouldn't be open to the internet. This resource has sensitive data and is being accessed in a strange manner. Those are nice, succinct phrases that an analyst can understand perhaps a bit better and then think, I should be diving into this. So, don't know what more I have to say for that. Trying not to talk about GPT all the time every week, but this, I think, it was at least worth a mention.
I think it's cool that it's a positive outlook on GPT, which is a nice, refreshing take after GPT is going to help people write malware and it's going to ruin the world and everyone's going to explode. One thing I wanted to say was that I think it has also interesting implications for developer education, as well as educating your company about cyber best practices in general. One thing that I hear repeatedly is that there's this really large gap between the people who work on the security team and the people that they're trying to get to secure their stuff, even if it's just passphrases and phishing emails and things of this nature. Sometimes translating technical to layman is really difficult, and I don't see why you couldn't use a tool like GPT-3 to help you in this endeavor.
That's interesting. I'm going to admit I'm skeptical on that point. I see GPT using something like, tell me about the OWASP top 10 as if you were a 17th century pirate, and it turns into R's and mateys. That's fine. I'd be curious to see if it explains with correctness, because I think one of the things that have been pointed out anecdotally is that ChatGPT is really good for explaining something and giving justification based on false premises or based on, it's highly confident, but incorrect, which honestly could still apply to perhaps some people within the application security industry or within the tech industry as well.
Right.
Confident but incorrect is not necessarily the best combination. So we'll keep an eye out for that to see what kind of content gets created. But I'm rushing quickly because before we run out of time, I wanted to highlight some tools as we've been trying to do. We've been trying to every episode have a question from listeners. So listeners, please do send us more questions that we can answer for you. And we love to offer up tools that we find interesting or appealing. So tell us what tools you're interested in. And Akira, why don't you tell us what tool you chose for this week to highlight?
Sure. So I chose a SAST and SCA tool called Sneak. It's very popular. What I'll say about it is that I've only recently started to use it. I've used it for a couple side projects, and then, of course, at an enterprise scale, I've used it before as well. But one thing I wanted to highlight about it is not only is it actually very good as a SAST, there's a couple things that you can do with it. The first one is that you can actually automatically fix some vulnerabilities that are within your source code, such as maybe packages that need updating and things of this nature. The second thing I want to highlight is that their developer education resources are fantastic. They have courses that teach secure coding. If you have a vulnerability, you can go to their academy and learn more about it. And I just think that's really great, especially if you do have developers that are interested in this sort of thing, or if you're relatively new to AppSec and you need to learn about a particular vulnerability and why it exists. I'm just really impressed with the Sneak offerings on that note.
Very cool. Yes. And to be clear, it is a commercial tool. So it has, I agree, has a great reputation for software composition analysis, for example, and does have some freely available ways to go and just review what is its current view of different NPMs within the NPM.js repositories. And I think more importantly, for anyone to consume that educational content, because that's one of the areas that we do want to try and highlight more as we talk about last year about AppSec education within the university level, as well as just what freely available resources are available to anyone learning or wanting to learn more. My tool that I chose this week was SQLMap. SQLMap is well known. It's a pretty venerable tool within the AppSec arsenal, and it's the go-to tool, I think, for looking for and exploiting SQL injection vulnerabilities. So I think it was a nice pair it felt with SQL Slammer that SQLMap command line tool it has knowledge of context about tables, capabilities, quirks across perhaps 24 different databases and many, many different types of injection techniques, from the very dead simple, which is my favorite phrase, of just using an apostrophe followed by SQL commands, to blind SQL injection that are time-based inferences, other logical-based inferences. If you're targeting MySQL, you can do a lot of union-based stacked queries to get more and more data, as well as even calling out things like local data in file, basically using through a MySQL database, getting not only the data from the database itself, but getting into the file system and files on there, depending on how poorly configured it is or how poorly isolated. So SQLMap goes into my arsenal for this week.
Awesome. I'll have to check that out.
And that does, we always have more articles than we can handle, but any parting words, Akira, any final thoughts for our listeners?
Oh, man. Oh, now I'm on the spot. Oh, wow. Definitely educate yourself. Get into some of those resources from Sneak. And of course, there's many other options as well. But especially, I guess I just want to say this to the people beginning in AppSec is don't be discouraged by how expensive some courses are. There's a lot of free resources that you can find.
Wonderful. And we'll continue to collect those resources and make sure we'll drop some more into the Discord. I think because there's a couple links that you mentioned that we can throw in there as well. Thanks, Akira. Want to thank all of our listeners for listening as well. Thank you for joining us once again. Do please subscribe. Hit that like button, check out the show notes. And speaking of things 20 years ago or more, the Sisters of Mercy are touring again this year. So go check it out. Go check out some Sisters of Mercy. Any of their tracks, they're all good. But Floodland in particular part, I enjoy. And with that, we'll see you next time on Application Security Weekly. Be seeing you.